Very happy to be here. Very astonished from your building. It's my first visit here, actually, just in the center. I'll talk today about how can we use a method of closed loop to study and try to characterize better what is mood. We'll go maybe a bit more into the intricacies here of the definitions. Mood, what do I mean when I say mood? What maybe you think when I say mood? So we'll try to define it much more, but many things will still probably be left ambiguous, as in this topic. So I'll try to go over these points. And we'll first talk a bit about why do we need to study mood at all. Most of it is kind of trivial, so we will not do it for too long. Just to mention a few facts. We'll talk about the challenges of studying mood. Some of it is just general challenges of studying humans and behavior. Some of it are more specific to mood and measuring it. Then I'll describe a bit how we try to do it somehow differently with our methodology, and I'll give a few examples of the projects that are ongoing in the lab. So I'll mention the lab is new. It's almost 3 years, but with all the building, I don't know, architecture and infrastructure that you're busy with in the first few years, it takes time. Any technical issues? רמקול.
לא יעני.
So it's back. We were almost done very quickly, but so I'll give a few examples. So most of the projects are really at their either initiation or still analysis phase, but I still want to talk about the new things and the things we are kind of striving to study now in the lab, although most of it is unpublished or really just open for discussion. So it's some very preliminary results we have. I'll be very happy to hear feedback, questions, ideas, and I'll talk less about older stuff from the postdocs. So it will be a few examples, very broad. So you'll see we try to do different techniques, we're kind of still starting a few different paths. So it will be brief examples, and I hope I will not confuse you too much. So why to study mood? So somehow it appears that each one of us can respond completely differently emotionally to the same situations. And this response that we all know from our daily life can also influence a lot of our different functions. So it's not just our well-being, how do we feel, and how happy we are. Eventually it also influences our decision-making, how do we choose to do different things, long-term, short-term. It affects our memory, and many studies have shown that the valence of events can affect how we remember, what we remember, how strongly, and more studies show how it can also affect our physical well-being or health, our immune system, microbiome. Today it's kind of growing the field of showing these different connections. And I think we can also know it from ourselves. So during the talk, you will feel how mood changes and these different fluctuations. It can be from moment to moment. And we can have longer term fluctuations of our mood over years. And we all know how even when we just receive maybe a simple email of rejection of a paper, grant, whatever, how our emotional response to what was written and how we received it will influence our motivation and how fast we start working on the revision and how do we respond functionally to this. So this has kind of a wide effect. I don't need, I think, to mention, but of course mood and aberrations in mood, changes in our mood dynamics are a very pronounced symptom of several mood disorders, and these are today, for example, depression, an ongoing, growing, almost pandemic around the world, across any country. And the main feature there is that you report low mood subjectively when you're being asked, how do you feel? It's embedded within questionnaires, but eventually this is what we have as diagnosis, and then you report that you feel low mood. Chronically, it doesn't matter what the events that you experience, and do you do something fun, nice or not. Okay, so eventually all of this comes up to this one question in different forms of how do you feel? And we search for the subjective report or notation of participants or patients, and we don't have currently some quantitative or more objective measures of this concept of emotions or mood. So we rely mostly on this subjective experience. This makes our diagnosis less effective and changing around between different clinicians, and over time the monitoring of this disease are problematic. Questionnaires usually ask you about the last few months, weeks. They don't ask you from moment to moment monitoring of your emotions, and the treatment is also kind of lagging behind other medical fields where there are more advancements. So the challenges of studying mood is, if I envision what we would like to do in order to have this kind of additional measures that can help us, is we would like to change somehow mood and shift it between different states. And at the same time, we would like to measure what happens in other systems and signals in our body. So it could be neural signals, physiological signals. We would want to search for some correlations, something that reflects changes that are created in our subjective state and can somehow infer maybe about other signals that are measurable. But changing mood, so doing what I just showed, is quite problematic. Typically, it's been done for more than almost 40 years in a task called mood induction. So there are many, many labs and studies trying to induce different moods in participants and measure what happens, how their responses are different, how do they behave. And these usually are being induced with several methods, quite popular ones. We can show a short movie, video clips that are kind of identified as being positive or negative. This is validated usually properly with many subjects. And there are picture statements, recollections. Sometimes people will tell the participant, please think of something happy that happened to you, something that makes you feel good. And after a while, they ask you again, the same question. So how do you feel now? Okay? So we sometimes even direct the participants during the experiment what to feel. And so you can already start thinking of the multiple biases of such experiments. And for example, I give another example here, I'll read to you, but there is a large meta-analysis of more than 11 such methods and experiments, and I'll just read a small part. The effects are especially large when subjects are explicitly instructed to enter the specified mood state, or effects tend to be smaller when demand characteristics are controlled. So demand characteristics are such biases that the individuals understand, okay, this experiment is trying to make me happy, and unintentionally, because this is our kind of a human nature, they just try to comply with the experiment, with the goal of the experiment, and they rate that they feel happier. Okay, so this is a big bias. Another thing is that it was recently identified across many a very large data set of both resting state data, where you just stared across like the classic fMRI resting state paradigm, or just very simple decision-making tasks, behavioral tasks, that if you ask participants how do they feel while they're doing the task, there is a very robust decline of their mood during this experiment. Okay? Usually in resting state, we analyze default mode networks, different interactions, background neural activity, but we don't tend to ask how do you feel. And there's this, it's almost like a negative mood induction when the mood goes down. And this is something that experiments do not compensate for, or do not consider this adaptation to the experiment over time. So we have huge individual variability, both within, between individuals. The effect sizes of these tasks are relatively very small to other behavioral tasks. The range of mood that we can induce, usually very narrow. Experimental biases, but the most important thing, as I see, is that the stimuli themselves are not scalable. We cannot make a movie now 2.3 times happier, or we cannot parameterize our experiment, and the stimuli are not quantitative, okay? So they're usually qualitative, and they are very subjective. At the end of the experiment, we find out, okay, who responded to the experiment and who didn't. Okay, so how can we address all of these challenges? With a bit of a different method. So we use, in order to create these mood changes, feedback task. So it's called, it is using a closed loop algorithm, but just because of the origin where it came from, it's in my PhD I was doing actually closed loop stimulation of neural networks in vitro at the lab of Shimon Morrow, and there I was creating this closed loop stimulation paradigms that shift networks synchrony and the activity between high and low states, and we were studying how this affects the trade-offs, the interaction between different neurons, and how do they synchronize well or less the trade-offs of that. So using exactly actually the same algorithm, the idea was we have some input. You know, this is most kind of widely used algorithm in so many systems around us, so air conditioning, in flight control, where we have an input and an output, okay? And the output is being all time controlled in real time by monitoring and adapting the input that we provide to the system. So I think the most famous example of this closed loop circuit in scientific research in biology was Hodgkin and Huxley, where they clamped the axon and actually controlled with the same feedback loop the voltage of the axon, and then they could measure what are the underlying ionic currents that identify the action potential. Okay, so this is the idea was to use the same strategy to try and identify what are the underlying mood forces, upwards or downwards. Okay, so we have output, which is mood, but what could be the input that we use to modify mood? What could be the input that we change over time? So this is kind of a hint that goes towards the reward processing world. And when I was searching at the beginning of my postdoc for what could be such a quantitative stimuli that I could modify in real time to change mood, we came across a huge field of studies that are studying differences in reward processing, both between depression and healthy, and as a result of that, the effect on mood, chronic low mood. So in this example, we found that across 43 papers that had fMRI data coordinates for the differences between healthy and control, there was blunting of activity in the reward processing region, with the dopaminergic region of the striatum during the receival of feedback. So from that, and going forward into deeper to the rewards, I came across the reward prediction errors. All the studies that shows that first here in monkeys, how we have in the same region in the brain specific neurons that fire stronger where we have positive prediction error, and they are inhibited when the prediction error is negative, and how this feature parameter is a key feature in our behavior, in our reinforcement learning, change and adaptation of our behavioral around us. And then came the study that showed the same in humans too. Okay, so it showed a direct relationship between reward prediction errors and subjective mood ratings. But this was the output we were searching for. So I'll read quickly from here: momentary happiness. So again, when I say mood, I mean momentary assessment, not long-term changes in response to outcomes of probabilistic reward tasks explained not by the current task earnings, but a combination of reward expectation and reward prediction errors. Okay, so from here I'll give just an example of what is this reward prediction error, just a quick intuitive example that this is how the task also kind of based on. So if I tell you have now a trial and you can receive either 0 or +5, let's say dollars, okay? So I give you these two options, and then you receive the outcome. So now you got 0, and I ask you, okay, how do you feel? So most of us to some extent will feel either disappointed or kind of less happy about this result. But if I give you a different trial, and now the two options are either to receive -5, meaning you give me $5, you lose, or you get 0, and I give you now the outcome is again 0, okay, you didn't get anything. So you might feel differently about it, but the thing is, this is all about this prediction errors, it's relative. In both cases, you got the same, and in fact, you got nothing in both cases, so you didn't win or lose. But emotionally, that's what that study tried to show. This has a stronger effect about how do we experience this event as positive or negative, and as a result, how do we choose to act next? What is our next decision making? Okay, so we created this task using the same principle of a gamble. So you have this kind of a decision making phase where you either choose to gamble or not. On the right is the gamble, on the left is the certain option. Then you have this phase where you await between different two options. One is typically positive, one negative, and then you receive the outcome. So I give you a bit of a more realistic kind of example, we had multiple versions of this task, and you see the values can be either very strict or very kind of minor differences. Every few moments, you rate with this slide how happy you are. So you move either right or towards the left, and you show how happy you are at this moment. And then we use this as our output, the rating of the task, of the mood. And again, I want here just to emphasize that this is a momentary mood, just from moment to moment. It's less than a minute that you receive this question repeatedly. We only, as you see, address here valence, happy or unhappy. Of course, there are multiple constructs of mood and emotions that we quite ignore at this moment in this task. And the scale is very limited, so it has boundary effects, right? You start from the middle. There are different limitations of this version of the task. As you can see, I don't know, quite surprisingly, individuals are affected by this, sometimes very minor differences in these rewards and outcomes. So if we see different for subjects, just experiencing this random task with shuffled random values, their subjective ratings are quite different. Some are not as sensitive, some are quite intensely reacting to this task, and there's a lot of this variability that we expect between individuals, but also within an individual during the task. So what we want to do here is to close this loop, use the mood ratings to either increase or decrease mood towards a certain target to reach different states. And we use here a PI controller, so this difference between our mood that we want to reach and the current mood is being recalculated also just proportionally, so the farther you are from the target mood, the stronger will be the next stimuli. And there's also this cumulative, integrative feature that's the most unique, or I would say sensitive part of this algorithm that really accumulates error over time. So imagine I keep rating my mood as 80%, and I'm far from 100 in 20, and I keep do that over and over and over. So if I only had this proportional component, I would just be stuck at receiving quite a similar amplitude of the next stimuli. But this cumulative feature allows this error to grow over time, even though my error remains constant. Okay, so it allows this fine-tuning, reaching towards the target mood. And here we see just an example, a typical open-loop experiment. Imagine we just create some scale of rewards, right? We predefine them before the experiment, and we have some set of values, and some individuals will really be around sensitive to this range. So this is around their sensitivity response curve. But other individuals will be outside of this range. They will not respond to our experiment, or will not evoke any changes. So here, the adaptivity of the experiments allows us to choose a different range automatically for each subject, and in real time change and kind of adapt the scale and the range of rewards to the sensitivity of each person, and his mood sensitivity. So this is how it looks in the adaptive version relative to the previous. For example, we saw that were random and mood was just changing differently for each one. So we see three different examples. So one is a version of the task on top that is aiming, so the target mood we want to reach is in blue, and it aims to reach these fast mood transitions between upwards and downwards, and we see each curve is a different participant. This is the whole sample here of specific data collection of 80 people. Then we see a slow mood transition with longer blocks and just 3 different states. And here I find it most interestingly, but the task can also clamp your mood. So this is something that is very, I don't know how you can do it with a regular mood induction, that you monitor the mood and you try to stabilize it and keep it at the same state that you want over time by modulating reward prediction errors. And now what's interesting here, this is an example for the middle panel of the 3 different blocks, that the stimuli each participant receives during the task are also different. So these are the RPEs that the algorithm generates during the task. And we can see that each one has different value overall, higher or lower RPEs that they need, but also different dynamics over time, right? So someone can have much faster transition of RPEs, and a different person can have this more moderate. So this is our kind of main, also outcome of this that we explode. Yes?
So how do you know that if you just use an open loop system where you just give rewards all the time and then you never give rewards, how do you know you wouldn't get similar results?
Yeah, so we didn't know it. We had to test it. And I can say, but in the paper, there's a comparison between open loop and closed loop. And you see that to some extent they are similar until some point. But after some point, individuals start declining down, like what I showed at the beginning in a different paper of no context, but you just go down. So they stop responding to the blocks, which are open loop blocks. They adapt to the values, and you can't continue to shift them. And the closed loop keeps increasing values and therefore can create a more continuous long-term response to the test. Yeah, it's a good question because this is like the first test that you have to do. Yeah. Okay, so these are some examples. I talked about the changing of mood part of this whole triangular that we're trying to somehow maybe identify one day in the lab. And there are different projects, and all use the same methodology. So from mood synchronization between different people, we have mood changes in psychiatric patients that we study in the hospital, Ziv in the north, and we try to modulate the mood dynamics across different diagnoses and how predictive they are towards their treatment response. We have different projects, but I'll talk now about one example of how we use this task to study stability and actually the reliability, both of the task but also of the mood trajectories. So there are different kind of findings that show that mood can be, on one hand, very stable. So this is kind of an example. I think it's very, talked about kind of studies, always on the media, that when you ask people to just rate their well-being after many years, so there's this recovery after very dramatic life events. So there is even a marriage, death, they all kind of come together and laugh, and people tend to go back to some individual. I put like an image of homeostatic kind of mood state. It's their individual kind of state that they go back to, which is quite surprising. On the other hand, as I showed before, we have these mood fluctuations from moment to moment while we're doing just a very simple task of 15 minutes. So what are these kind of stability versus instability and our individual traits of mood versus our individual, adaptive features of mood? So the next kind of experiment used many different data sets. So it's a bit confusing, so I will just describe a few. But the question was this. So one individual can respond with a very similar amplitude or range of moods to different situations. So we can come to work and something happens and we'll have a very certain kind of response. And the next day something else happens and we will respond quite similarly. So we are kind of stable individuals with some trait of range of mood. And other individuals can respond completely differently. So they sometimes respond very strongly, sometimes it does relate to many different, also disorders, bipolar, but also our kind of, just features of, so to test this, to model this question, we use different repetitions of this task. So before I show just data of one repetition, now we had 2 sessions of doing the same closed loop task. We had sessions separated by 1 day, sessions separated by 1 week, and we had sessions that are interleaving between closed loop and open loop task. So there were different cases that we flipped between the different tasks, trying to find when people behave similarly even though the task is very different, the rewards are different, and when they behave differently, respond differently to that, and to model that. So I give you a few examples of very stable individuals that do the task in 2 different repetitions, and they actually reach, kind of touch upon a very similar range. So this was very strange to see. This is part of the data of the open loop and closed loop comparison, but some individuals kind of reach the same range. This is their maximal and minimal mood range over different repetitions. And we saw that, in fact, yes, there is a mood stability of individuals that's varying. Some are more stable and some are less. So we tried to model this with a model that was published a few years ago. We call it the primacy mood model. And it has a few parameters. First, the mood ratings by this model are including our baseline mood, so some intercept of mood over time. And to this, we add primacy-weighted outcomes and another parameter that represents a recency-weighted outcomes. We call one expectations, one prediction, but at the end, this is how we calculate it. So it's the average of previous outcomes. This model was actually going kind of in contradiction to all the previous models of subjective mood. So there are a few models that all had similar parameters of outcomes, expectation, prediction errors, but they all had an automatic kind of assumption that there is a recency weighting of previous outcomes, that the most recent outcome you experience will be most influential, like in memory models. And in this model, we calculate when we use the adaptive task with the closed loop, it didn't fit as well. So we had to change and modify the model until we found one that would be better for the adaptive data. And then it was overall across several data sets better in general. And that model was different in having a primacy weighting. So it means that the first few events had a stronger influence on your mood over time, and in order to shift your mood, remember we saw the RP values during the task that they were actually increasing over time, decreasing over time, so it relates to that too, that over time you need stronger stimuli or a larger amplitude in order to affect mood as much relative to the beginning. So while in other fields there is a primacy, other primacy works, and in mood it was actually the first demonstration of that, and we also made sure to compare this model to brain activity while they were doing the task, adaptive task in the scanner, and showing that the primacy weighting of individuals of the weighted outcomes was correlated to the specific region of activity around the ACC that is related previously to value, valuation, to rewards, and that had a correlation. So the more you had your weight in the model was a larger value, you were more sensitive in your mood to this primacy outcomes feature, the stronger was your activation in this region in the brain while you were rating your mood in the task. We compared this model, thanks to the reviewers, to 13 different other models and 5 different data sets. There were different ages, there were healthy, depressed, there were different environments of rewards, closed loop, open loop, random, context, no context, and there was also different experimental settings, okay? So we here use the same reward model and try to model our repeated sessions. And this was done by the postdoc in the lab, Kirill Vasilchenko, that actually is a psychiatrist but was working here on this and not on the patient data. And we had these main parameters to test. So we mostly will here focus on the primacy weighted parameter and the recency weighted outcome. So each of these weights is different for each individual after we fit the actual mood ratings to the model mood ratings during the fitting process. Okay, we had here 2 measures that we tested for each of the parameters. So we had different time delays of the tasks and different or type of task, and for each one we looked at the reliability using the ICC measure and just the correlation, so between the 2 sessions. So we call that just stability. And as I show here, the values don't matter, just the beta A weighting parameter was most consistently, significantly reliable across 2 sessions, across different tasks, different time delays, and different data sets. And here we also see that the beta A parameter showed also graphically, when we look at the scatter plot, more consistency across individuals between 2 sessions, which suggested that this parameter is more, refers more to whatever is stable across sessions. So we're searching what is the parameter that remains consistent and what is the other parameter that remains inconsistent. What kind of drives fluctuations versus similar dynamics, stability dynamics. And here, interestingly, we looked at how large is this weight in different individuals and whether that is related in any chance to how consistent their mood trajectories are. And then we also saw, just for the beta A parameter, that whenever this weighting is larger for individuals, their mood stability across 2 sessions was also more similar, so higher stability. So again, it's to us just as suggestions for now, but that the sensitivity to the recent outcomes was driving the stability and not the primacy. Okay, then we looked a bit farther, we just raises another suggestion that to us is still another question at this moment, but what happens between the closed loop and open loop sessions? So do we find similar, we had them in a crossed order kind of fashion, so do we find a similar stability whenever the closed loop is first or the open loop is first? So we found here, we took data set of these 2 sessions that were changed in order. And here we saw that the stability of the mood trajectory, so how similar these mood values, the range of mood that individuals keep, is higher when you start with the closed loop first, and then you do afterwards the open loop session. So it remains more similar. We could also just see it in the data by eye, versus the opposite. So when you first do an open loop session, which is kind of, we'll call it more spontaneous mood dynamics and limitation, and then you do the closed loop afterwards. And the closed loop, as you remember, pushes us like to the maximum. So for us, when we see closed loop mood range, we assume that we reach kind of a maximal mood diversity to this certain type of rewards in this certain type of task. Okay, so this whole question was about trying to see whether individuals, when we push them with this adaptive task towards some maximal and kind of stretch their mood range, do we find anything similar in their spontaneous kind of mood changes, or is it completely different relative to this reward environment? So another example, just showing that now in the lab we replicate the same task and the same study design, also with the repeated sessions in VR. So we kind of built the same structure of blocks, gambling, decision making. Everything is there. So we have mood, we have expectation, we have prediction errors, but we added to that like a whole new vector of measures and parameters. So here we have in closed loop also changed the environment, weather, colors, sounds, and there are multiple features that are being kind of changed simultaneously. So as you can see here, this is like an example for a positive block. You go colors, I don't know, flowers. Maybe here we shift to a more kind of negative setting, which is cloudy. There are crows and different sounds, lightning that are less pleasant. And this is a project now being in data collection of EHAB in the lab, who developed this. thing. And now we go to the other two features that we didn't talk about, and I'll just kind of mention that the plan overall to characterize this whole full triangular and have somehow also some causal interaction and from some knowledge beyond only correlation is also to try and modify next neural activity. And we study now these mood changes and transitions in fMRI, and also then to do that with physiological measures. So currently we measure eye tracking and HRV, and next time I really hope to provide the results in these two projects, because these are now really kind of ongoing and the data is accumulating, but it's still too early. But I want to just say a few words before we finish about why HRV. So I don't think we need to talk about the neural signals, and this is the mood. I kind of talked too much probably. So just to give a small kind of short example for why now in the lab we take this heart rate variability measure as one of our kind of main measures collected in all experiments and all our analysis. So I'll just give a quick explanation and just a reference to go to, but this is a small review that we just published in the lab that talks about this interaction between HRV specifically and depression. And what we looked here is, okay, HRV is this kind of intervals between consecutive heartbeats. And the more variable this is and inconsistent, actually we are more adaptive to the environment, to the state, to stress, to different things. So the higher HRV is, usually we are more considered healthy, and in depression and other disorders, HRV is lowered. It's significantly lower. So we asked here about the temporal relation between HRV, lowering aberration, differences in HRV, and the onset of depression. So far there were many studies and meta-analysis, and everyone addressing this group difference between healthy and depressed, showing lower HRV in depressed. But there was no answer to this chronological question of what seemed to happen first. Is it that we first become depressed and then HRV becomes lower, probably due also to medications, or could it be the opposite? We were hoping or searching whether HRV might be changed first, and how could that be happening mechanistically to influences eventually depression, because then it could be a marker that we can track and we can search different relations to mood as we do now in the lab. So mood differences that are momentary could be measured with HRV. So here what I show is just after a very, very, very long search of Shir Galin, who I showed before, and very hard work, she found these studies that show longitudinal studies, twin studies, different studies that we can rely on as a chronological relationship, where HRV was changed first, this was the association, and depression came later. We couldn't find a study that was showing the opposite relationship. And from there we moved to presenting, and in the review just really elaborating with many, many wonderful references there, the different pathways that this might happen through. So there was changes in autonomic system that can lead, and we describe how can that lead eventually to depression, different shared brain regions that are being aberrant in their activity, and how from that we affect in parallel both the vagus and the autonomic activity, HRV, and later on emotional regulation that will lead to depression, and even all the way to inflammation that also we showed in different papers how it affects both, how one can lead to the other. And this is kind of a presentation of the coordinates we found for the different regions that are encoding and regulating HRV and autonomic activity, and the regions that were shown to be related to depression. And we found that the overlap is around the insula, and this is now our kind of first target region in our fMRI studies that might show this relationship and interaction between the whole triangular that I showed before. So we kind of put our hopes to that region. So this is both top-down, where we have different central nervous regions with aberrant activity influencing backwards like the HRV, and we have a bottom-up where the peripheral changes can lead to evoked action potentials that were shown with EEG, and then lead to depression in that way. The hope was that this is just the first kind of step to continue investigating HRV as a potential biomarker. We'll have studies of HRV modulation, and we hope we found so many papers we're doing now in meta-analysis of HRV and subjective mood, so not depression, but just actual subjective mood like in our task. And we found more than 13,000 papers at the beginning of this very long, difficult journey that measure both HRV and something related to mood depression questionnaires. So it seems that HRV is both clinically very useful measure being taken in any admission to the hospital and also in many research, so we kind of try to bring it more to this world of emotions and mood. And that's it. I go back to our kind of overall question, I think, of how can we integrate between these different parts and our kind of aims of the lab, starting from the mood modification, the neural physiological modification, while measuring the other parts, and we do that also in psychiatric patients. So just a few pictures of the lab. It's located in Tzfat, in the middle of the old city, so we went through a very long phase, more than a year of building and structuring and all this different equipment. And we now have a team that I really like. It was my fantasy to have a team of many different diverse backgrounds of students. So we have from Anton was a mechanical engineer and actually an aeronautic engineer in his master, worked for many years in flight control companies, closed loop control, and we have a psychiatrist and a psychologist and MD PhD student, and each one talks a completely different terminology and language when we discuss. Every discussion in the lab really just fascinating, and the arguments are wonderful. We have Baz Arel, who is just the technical aspect of all things. And this is this device of the VR I told you about. So you just can stand inside and walk and turn around completely. You can even jump. So when you walk, you're not limited by any room kind of size or obstacles or anything. This is how we create this environments, and this is, they also, while they work and do different things, this is our fMRI scanner where we scan, we do fan, just some, this is the view from the building, from the roof. If you, I don't know if it's familiar or if you ever end up with the alleys that used to be, but we try to somehow bring back some more academic culture, but some culture to these alleys that I as a child was walking there between galleries as a tour. So this is our building of the lab, and the view from the office. And thank you for listening.
Thank you very much. I have a question about the art, whether you think that a generally more positive or negative environment, do you expect that to kind of shift the mood down and up, or do you think that could stretch the limits of the, right? It seems that the subjects there are certain limits that you reach the maximum and minimum,
So the first question is exactly that. Can we stretch limits? Are we limited? Is this range is just due to our setup, to our task being too simplified, too boring? So can we stretch more using something more realistic and exciting? But the second question really kind of touches upon the prediction errors. So we actually don't know what will we find out that the more everything is possible in this environment, because we have these multiple features, you're just becoming happier, and the more everything is negative, or that actually eliminates the prediction error kind of strength when you have everything positive. So we're trying these different environments where it's kind of going opposite ways. So perhaps prediction error and rewards will have a stronger influence if all the other features are now negative and only rewards are positive. So do we need this difference? Is it really relative in our kind of, more naturalistic behavior? Or do we need just an intense experience where everything is more positive? So it's also one of the questions there.
Are there studies that show if thinking of mood as just a single variable that affects everything, is a good approximation of our internal state? I could be sad and curious, or happy and tired, and everything here falls on just one axis of mood happiness. Is it a good approximation for this?
No. It's definitely a very limited, and I hope we would have this measure where you have all different moods and people can really navigate in the space of anger, frustration, and excitement and tiredness. It's all true. But as we try to have this, one output that we try to control and understand something about, an input, we have to somehow, we had to simplify everything at the beginning for the tasks to just understand where we're starting from. And now I think we try to increase it back. So the VR will add maybe more kind of context to the environment, to the input. And this would be the next phase, of course, one day to add more context, more richness to the output and have more complex moods and emotions and states of the individual. Yeah. But we also need participants that are willing to do this very complex and not get tired.
I have a small technical question. How do you model mood? Just tracking the RPs, the average estimated RP?
So model mood with just the average RPs?
I'm asking how are you modeling the mood? Are you just estimating the next RPE? Is that the model, or is something more complicated than that?
So the model is fitting the next mood rating, not the next RPE. And this is what you meant?
Yeah, but what was used in order to calculate?
Okay, so the parameters I showed included, we call it RPEs, and they included baseline mood expectations, so they are choices, the actual outcomes. We didn't include whether they choose risky or certain options, because when we added that or eliminated that, the model was as good, so we prefer to have less parameters. But eventually, how I described it, it's the more correct. The prediction errors were just the sum, weighted recency sum of outcomes.
Outcomes of
outcomes
errors.
Of outcomes. And the expectations were modeled as the average, just unified average of all previous outcomes. And that created the primacy weighting. So I can maybe
So
later.
the mood rating was predicted using the outcomes, not the RPEs.
Eventually, in this model, the stronger also weight was the outcome. Yeah. But also in the previous model that I showed, the RPEs were the strongest. So RPEs were a difference between outcome again and the two options. So it's also not the most optimal kind of, I think, we can think of more realizations of RPEs in the model. It was also quite like an estimated kind of RPE.
Do you know if people report that they're happier when they walk compared to when they are stationary, or if there's some dynamic in time?
Next time I'll have an answer to this. We are collecting now the VR, and this is we made sure to really measure the distance they walk and how fast they walk, and so we can try and relay that as another feature. Because usually we only have the response time. This is like a very limited behavioral, but this is the most used parameter, so now we'll have more. So we'll see.
How much is mood a matter of one's decision of what mood he wants to be in? I mean, maybe I want to I'll decide I want to be positive, and that will locate me in some other region in the mood, or in the end, it's a matter. I don't have much control. I mean, whatever. I don't have much control over that. where I am.
Yeah, there's so many like unknowns like this. Comes to mood, I think we do know that in depression they tend to continue kind of wanting, or I don't know how to call it, to rate their mood very low, even though they show other very positive responses to treatment. So they could go back to school, create eye contact, smile, communicate completely differently, join activities. So the NH, in the inpatient unit, we had the adolescents, and we could really see when we do experiments with them, they change very strongly, but they continue rating their mood on the questionnaires as very low. And this could be some of the effects or what drives this, that they just kind of used to be in this state or want to remain in this kind of, so we don't know. But that's why we search for something more objective to rely on.
Have you looked at whether not just accumulation of reward prediction error affects the mood, but also the volatility? Because I could imagine that the same accumulated RP would be very different if it were going gradually down, increasing, gradually increasing, or a great deal.
Yeah. So here it wasn't included. There was one type of a model that included like the difference between the control, maybe something related to it, but not directly, but there are other works. So I think here work by Terry in France, they did like a whole study just about both reward environments and how that is reflected in the brain and how it relates to mood. So but they touched upon that kind of question. It is an important feature of the environment.
Okay, so if there are no more questions, thank you very much.
יש עבודות ספציפיות שמדברת בסיטואציה הזאת יש את העולמות באלסקי נגיד שיש לנו אנשים מדברת סביבה יש את האנשים שלדחוף אותם אנשים להתנסות בתחום הרפואי ממש יש הבדלים עכשיו השאלה אם אני קוראים שאני עושה גם וגם נותנת לאנשים את ההגרלה הספציפית והם גם חווים אותה בצד שלה
גם ניסיון וגם איזשהו אולי חיוב למה הולך לקרות
בעיקרון לא חושב למשהו גם את האינפורמציה מלאה על מה מסתבר שאנשים לא מתנהגים ככה אנשים באיזשהו שלב מתחילים להתעלם מהאקספליסיט ורק להסתמך על מה
זה כמו מה שאתה הראת, תשואה לראשון בעצם.
משהו אחר, ראיתי אפקט של תואר ראשון במקרים שבהם ההגרלה היא לא אקספליסית. אני אומר, כשאתה מצב שילוב של אקספליסית ואקספליסית, אני חושב דינמיקה שמתחילים בדברים שמתחילים באקספליסית,
מה שתיארתי זה מעבר מהמודל של רק בעצם לדבר את האפשרויות שמופיעות במשחק, שממוצע ביניהם, זה לא ההיסטוריה, וזה היה הפרדיקשן ארוך, ואז במודל שאנחנו עברנו עליו, אנחנו לא התחשבנו באפשרויות בכלל, לא נכנסו גם, רק הקודמים. נכון, אז אנחנו הסתכלנו רק על כל התוצאות הקודמות, והסתכל רק על הקיים. אבל היה מודל של סביב שלהם, להוסיף ולראות את הזמן, וזה לא היה איש.
מה שראיתי בשאלה מה קורה, בתחילת הניסוי הזה, לאורך הפרוג'קטור של הנבדק, הוא משנה את ההתנהלות שלו מליין זה אחד וליין זה שני. זה תוצאה ניסוי.
על המעבר הדינמי תוך כדי הניסוי, מאחד לשני.
זה מה שאני שומע.
אז זה הייתי מציע, לדבר את זה בצורה יותר דינמית כזאת.
אני יודע אם אני יודע, אתה רגיל.
חתך, זה או שמתעסק בזה או בזה.
מה קורה בהחזרת טרייז ראשונה.
ואז יכול להיות בסביבה יותר עשירה, שיש לך יותר גדולים, אתה עשו יותר דברים, אם אתה עובר בדינמיקה אחרת.
אני לא יודע, אני לא עשיתי אף פעם.
כי תמיד הניסויים הם מאוד בעצם לא ריאליסטיים כאלה, יש לך ממש פרמטר, אתה יכול לחשב, אתה יכול לזכור. נראה לי להשוות את המודל עם שני הדברים, בניסוי כזה וניסוי בגלל זה ממש איך המעבר שלהם לחשב.
יש בעצם שני זה או שהאוטקום של הטאסק יותר טוב ממה שחשבתי בהתחלה, או שהאוטקום של הרעיון הזה יותר טוב ממה שחשבתי שהוא יהיה עכשיו. זה שני רמות של RPEs. יצא לכם לנסות את המודל של, אני מעבר של הנדאפ, יש לו מודל של לימוד אינסטביליטי, שהוא קשור בפרסיב, בזה שהסכום, יש לו נוסף ללמוד ה-Q-Values, זה הרבה יותר של reinforcement learning, אז לומדים את ה-RPE המצטבר. עכשיו,
ששומעים? שבוע הבא, אמרנו לכם 9, 10 ועד 11? 9 עד
שוב יצא לי 10, כאילו עכשיו יצא לי שוב, RPE שוב,
רגע, קיבלתי על זה.
זה RPE מצטבר.
אני אכתוב לי בקבוצה. שהוא עושה לו את האינפורמציה ומשתמש בזה בתור משהו שעושה מודולציה על ה-perceived value. זה פשוט מודל אחר שאני עכשיו עובד עליו באיזה פרויקט אחר ואני תוהה, שוקל חלופות בשבילו. אז הייתי אם זה משהו שבדקתם אצלכם.
לא, אבל אני אשמח באמת, לא יודעת אם את רוצה לשלוח לי או לדבר את זה או להפנות אותי אז אנחנו יכולים לנסות לבדוק את זה. נשמע מעניין.
איזה, מי אצלכם מתעסק במידול של התוצאות בעיקר?
קצת כולם, אבל אני יכולה לחשוב על מי לחבר אותך שזה יהיה חלק שלו מרכזיותו. כרגע קירי לא הכי כבר סיים בעצם, כי אני לא תעשי את זה וזה, אבל אחרי לא משלב קצת אחר, זה...
יש טוב פרסומים של זה?
אני עובדת עם הרבה אנשים של NIH שזה, יש שם כמו קור כזה שזה שפשוט עובדים ביחד עם דברים ולהתעסץ, אז לפעמים... וגם לא עשינו פה דרך אגב פיתוח מודל חדש עכשיו, עכשיו שלי. אנחנו עושים למודל הקודם, זה גם קצת עבודה אחרת, סתם עושים למודל קיים, זה לא אותו דבר. לא, מה שראיתי עכשיו עם הסטביליטי וזה, זה לא פורסם, בכתיבה. יכול להיות משהו להוסיף.
יש קצת שנשמח לי.
בסדר.
שיש לך קצת.
תכתוב לי לאימייל ו...
אני מדבר עם קוראים, זה משהו שהוא פה, שזה לעבור אותו.
כן.
אני מדבר עם ערן, כשהוא יתחיל להתניע, אז אני עושה...
אני אשמח, גם אם לא זה, אז יכול להיות עבודה הבאה, משהו נפרד אפילו.
כי זה די דומה, אנחנו גם עושים דירוג של הדמופיל כרגע, אבל קונטקסט של פשוט ל-Words אחר, Words
חברתית.
ויש לך לשלוח לי איזה מאמר או משהו שאני יכולה להבין מה אתם בדיוק, כי זה נשמע ממש...
אז יש מאמר של ערן שעשה לפני 10 שנים.
כן.
עם Wheel of Fortune.
כן, כן.
אז שם, כאילו זה סימן משהו שהוא מבסס על זה בעיקר, שם יש לו ביטול אחר של המודל, זה מאזן. עכשיו אנחנו מנסים להמיר את זה לאיזה גרסה אחרת, ויש לי סייגים מהמודל הזה, אז אני מחפש מודלים אחרים שעלולים להיות טובים יותר.
טוב, אז אני יכולה לשלוח חזרה את המאמר הזה. תנסו לראות.
מה נשמע? הכל בסדר? מחשב שלך עכשיו?
לא, זה שלא שכחתי אותו, פה זה כבר נס. אני שירה כזה בכל מקום. משהו פה אני צריכה לחבות.
שלא תשכחי שום דבר.
רגע, אז עכשיו יש לנו את ההפי היום בעצם?
מה זה?
עכשיו.
יש עכשיו אוכל אם את רוצה בחוץ.
אבל זה ככה כבר שלא צריכה לחפש.
סיבות כל הזמן. את רואה מה זה? לא, לא. מה זה, כל שבוע מה? לא, לא כל שבוע מגיעים כל כך הרבה אנשים. תתעניינו עכשיו יהיה לשבוע.
כן?
כן. לא, לא, לא. בכלל לא.
בלתי... אבל סמינר אני צריכה בכלל שבועים.
כן, שבועים. עכשיו יש אוכל בחוץ, מי שצא. ואני אמור להיפגש לך, אמרו לי 3:30.
לא רוצה שתפסיק אוכל בלי...
מה שאת רוצה, אני לא יכולה להפסיק אוכל. מה שאת רוצה אוכל, אז תוכל לאכול. up to you. כן. זה לא קורה כל שבוע. שיכול להיות שבקצוע ראשון יש קורס קוגניציה שהוא חלקו מלומד